If you haven't ever been in a soybean field in Louisiana, it really it's mind blowing, especially in South Louisiana, how severe red bandits can get in them. I'm going to kind of shift gears a little bit. I've got some red bandit data on the backside of this talk, but this one is really, as an entomologist, there's not many things that excite me when it comes to the world of controlling insects, but you're looking at biopesticides or virus is something new that's on the radar as entomologists of us in the Mid-South. And so this is something that we've got a chance to work with pretty extensively. I borrowed a lot of the bollworm data from Gus and Nick and Ben up in Arkansas because they consistently fight bollworms much harder than we do. And so, however, I did look at the looper virus, and I'll have a little bit of data to show about that. So just a little bit of an overview of what an NPV is. So it's a nuclear polyhedrosis virus. And so essentially what it is you're spraying a virus onto the crop. The looper or the bollworm ingests it. The virus essentially takes over their body, and it will actually hijack their simple nervous system and cause them to crawl to the top of the canopy when they become sick and liquefy. And so what that does is it actually causes it's a better chance for the virus to spread across the field. So you're picked up by wind, moved by air, other insects. And so it's really neat to actually see this happen. What's really kind of advantageous to growers is the cost. So you're looking at, to control soybean loopers, you're looking at, let's say, 18 ounces of Previthon to really do a good job, 18 to 20. That's $20 an acre. Heligen, or even bollworms, for example. So you're looking at 18 to $20 an acre to control bollworms. Heligen's running 3 to 6 an acre. Now, there's some caveats with it. It's not going to work like a diamide, and I'll kind of get into that, but the cost advantage is definitely there for these viruses, as well as the resistance management aspect of it, because these worms don't become resistant to these viruses. I mean, this is something that we don't see that. If it does, it's extremely rare in nature. This product that I'm talking about, this is Ag Vitex product, so it's a company out of Australia. They have another product called Chrysogen. Chrysogen is the looper virus, so that's the one that just works on soybean loopers. And there's a jug mix, they call that Certivo Soy. So what they're going to do is they're going to take Heligen, and they're going to mix it with Chrysogen to get Certivo Soy. So they're going to have corn earworm, soybean looper, jug mix together. Now we may not see a fit for that for us in Louisiana, but Gus up in Arkansas, Angus in Mississippi may see the benefit of having those together. It must be stored at or below 77 degrees Fahrenheit and out of direct sunlight. It is a living, technically, whether you want to debate biology, virus is a living organism or not, it's RNA. I mean, we could go around and around about it. Let's just consider that it's a living organism. It's got to be stored at or below 77 degrees Fahrenheit. So when you go to the chemical dealer, you can't throw it in the bed of your truck, leave it there for a week. The virus completely becomes inactive, if it's above 77. And so when we're spraying for these guys, that's very common. It's only going to kill the target insect, so it's going to be species specific. So with Heligen, you're looking at bollworm, budworm. That's all that it's going to kill. Chrysogen, it's going to kill soybean and cabbage looper. Used to be Pseudoplusia, now it's Chrysodexis. The Pseudoplusia, Trichoplusia, Racoplusia, all those Plusia species, Chrysogen will work on, and then Certivo is a jug mix of the two. So with these products, identification is critical. So you've got to make sure this is a corn earworm and a tobacco budworm. You've got to make sure that's what you're going after. Same thing with soy. This is a soybean looper and a cabbage looper. It's not going to stop velvet bean caterpillar or green clover worm. So I get a lot of calls. Guys will send me pictures. Hey, I got loopers in my field. Well, it's not really a looper. That's a green clover worm. So identification is critical. Heligen is not going to kill fall armyworms. They do have another product I'm not going to speak about called Phologen. It's a virus for fall armyworms. So controlling these insects, it's species specific. And so, historically, where we have bollworm issues, Heligen may be a better product. Soybean loopers, that Chrysogen product. So this is some of the pictures. Gus lent me these pictures. He's got some really awesome pictures of how this virus works on bollworm. But you can see essentially the worms liquefy. They ingest this virus and they liquefy, which proliferates it out throughout the field. Our reproductive threshold for bollworms in soybeans is 9 per 25 sweeps. You can go out with a diamide at 9 per 25 sweeps, and if you get good application, you're going to kill those 9 per 25. You can't do that with virus because they're going to eat you alive. The real point to where we want to put virus out, 3 to 5 or roughly a half a threshold on small larvae per 25 sweeps. It's a caveat with virus. Virus is not going to really do well on large larvae. Your 5th instar larva, You want to target them second to thirds first if you get lucky. Second to thirds is about where you really want to be. That's where you're going to get better control. 4 to 6 days post-application, what to expect: reduced damage and feeding. You're going to see larval migration, a decreased defense response. The larvae are going to be lethargic. And so if you ever hold a corn earworm larva in your hand and you sit there and poke it, it's going to defend itself. So it'll sit there and try to bite you, it'll squiggle around. If you hold a sick larva in you and you sit there and prod it, it's not going to do anything. It'll typically just roll over and lay there. And so you can tell pretty easily when these larvae are intoxicated. It'll actually liquefy the larvae and cause them to sweat. Now, insects don't sweat, but what it is, it's almost exuding, it's like they're exuding hemolymph outside of their cuticle. And so it's going to be little water droplets that are stuck to the insect. So it's a weird phenomenon, but it's the virus taking over the larvae and actually causing them to what we call sweat in very extension terms. So these are some pictures of what liquefied larvae look like. And so, I mean, you see this, they're very infected. Those viral bodies essentially just disintegrate that larva. They leak out, and that's probably, I would say, billions of viral bodies that are being leaked out of that larva that are spread by rain, insects, birds, wind. This is one of the few insecticides that actually increases its activity with rainfall. So we're talking moderate rainfall. The company says 1/2 inch to 1 inch. Now, if you get a 4-inch rain, it's pushing it. But if you get a 1/2 inch to 1 inch, typically what we see in our pop-up showers in Louisiana or the MidSouth in the summers, you can actually see proliferation of that virus. And we saw that this year in my trial with soybean loopers. So looking at loopers, this was a field actually that Ashley Peters had over here. This was a location that I gave him a jug to take a look at. And Ashley may correct me if I'm wrong, if I mess up on something. So, our threshold for loopers is 37 worms, 1/2 inch or longer, 25 sweeps. Our NPV threshold, this was preliminary, so I took what we've learned on corn earworm and what we had our trial within Franklin Parish. Ashley's was at 1 worm per sweep, so he was roughly 25, so we were anywhere from 10 to 25. Just kind of, we're working on to get the threshold down, but that was more of a guesstimation. 12 to 18 per 25 sweeps is small worms. So you want to give it time to work, but you also need worms in the field to make that virus proliferate. So what we see is if you see a gap in generations, so let's say we get a soybean looper flight in, the virus takes them out, there's no more worms, that essentially means there's no more virus. And so it has to have a low level of worms to be able to keep going. So if you keep a low level population of worms in your field, you can actually see that virus continue to go throughout the season as long as you have to have the insects to make it work. 4 to 6 days post, we saw essentially the same thing: reduced larval feeding and damage, migration to the top of the canopy. Something interesting we saw with the soybean loopers is there were larvae all over the ground. And so they seemed to become intoxicated and let go of that leaf. And so you would peel the canopy back and there'd be dead larvae all over the ground. Whereas corn earworm, they seem to migrate to the top. Now you will see some on the ground, but this was interesting to me with the with the larva virus, soybean looper virus. So this was an example of what we found in our Franklin Parish location. This was 3 days after application. And so, actually, this was 24 hours after application. So the larvae are laying on their side. You can see they're sick. So he's laying on his side. They're not very mobile. And I didn't beat them really hard with a sweep net. This was just gingerly going through, knocking them in the sweep net. So if you swept soybean loopers, if you shake them around enough, they're going to be disoriented and they're not going to move. These guys, I actually just beat them off the canopy into the sweep net, trying to be gingerly with them. And you can actually see some of this guy's already starting to liquefy. This one's turned a different color. So this was 24 hours after application. So you do see some activity with this if the conditions are right. So this is a picture of one of the dead larvae on the ground. And so, you will peel that canopy back and see those larvae dead on the ground. And so your keys to your NPV success: it's a live virus, so don't leave it in the bed of the truck, and it's not a traditional insecticide. It's not going to be one of those where it's not going to be a diamide. Diamide's speed of kill is on par almost with the pyrethroids. There was a paper that was put out where when diamides first came out, they killed insects as quickly as the pyrethroids did. And so you're not going to see that. What I like to equate these two is Intrepid, or growth regulators. Intrepid, we had to train our growers what to look for with Intrepid. If you're not familiar with Intrepid, it's methoxyfenicide, or a growth regulator. And how it kills soybean loopers, it actually fuses their head capsule together, their mandibles. So when they go to molt, their mandibles will actually fuse together. And so they can't feed. So you'll actually see them crawl around on the canopy, but they're effectively dead. And so this can be kind of the same thing. they'll be crawling around on the canopy. They're not going to be feeding. They're going to be sick and lethargic. And so I equate it very much to seeing what Intrepid looked like when it first came out. Keep it cool. That's important. Don't leave it in the back of the truck. It's got to be stored. I store mine in a freezer. A refrigerator is fine. If you don't have that, you can keep it inside your house. Just something where it's climate controlled. It's not getting 100 degrees. The big takeaway, target small larvae. Targeting small larvae is key, because going after these big larvae, it's not really we're going to see some misses. And Gus has seen plenty in Arkansas. I know I've gotten a call on some where guys have made misapplications. They had large larvae in the field. They were using virus to target those, similar to what they would see with a diamide, Previthon, Besiege. It's not going to really work that way. You want to target these larvae small, at about a half a threshold, and you want to get in front of them. And so you allow that virus time to to be ingested by the worms, get in the system and the environment, and proliferate. Other insects will spread the virus. And so this is some fire ants feeding on dead larvae. This is a lacewing larva feeding on larvae, assassin bug, and then you have a tachinid parasitoid fly. So we do see other insects, typically predators and other parasitoids, actually feeding on the disease larva. And that, the fact of them feeding on this and then crawling off, is actually spreading that virus around the field. So these are a lot of these are very mobile, especially these assassin bugs are going to get up and move around quite quickly. Tachinid flies are extremely mobile. So if they visit different leaves, wherever they deposit or land, if they're bathing in virus, they're putting virus on those different leaf parts. And so you've got a kind of an aid almost in biocontrol, helping move this virus around the field. So limitations. So you have temperature. So typically viruses, when I've seen it in nature, when it happens, it's going to be right after a rain. We're really hot, we're really humid. I mean, it feels like you're breathing water. And so if you've got enough soybean loopers in a field, it's going to naturally will take off. Typically, our environment in the Mid-South is going to be very hot, very humid, especially in South Louisiana. So I think it would be a great fit for us to have that in that area, because we have the perfect field conditions to see it work. Limited scope of activity. So you're only going to, what I kind of elaborated on earlier, you're only going to catch the ones, either the heliothons, you've got a bollworm, budworm, loopers, cabbage looper, depending on what you're going after. You're going to have, it's very limited, but it's also very IPM friendly. You're not going to flare other insects. You're going to miss your large larva and your slow speed of kill. And so that's something that, you can see the worms are sick, but the speed of kill may not be as fast as people would like. However, this was the field that we had in Richland Parish that was on 15-inch center under irrigation. I mean, these were drilled beans, and so the canopy was extremely dense, kind of like what Harold was talking about. There was a nightmare to walk through. They were lodged and terrible. It could be, the beans are up here, and it's hot and very dry up here, but you peel that canopy back, and it's like a humidity bubble just boils out of those soybeans. The ground is still wet. It holds humidity very well. Where Ashley applied Besiege at 8 ounces plus a pound of acephate, and applied virus plus a pound of acephate, these are your pre-count numbers. At 4 days after application, it was equal to what we saw with the Besiege. Now, acephate's not going to have any impact on soybean loopers, as Harold had mentioned earlier. So you're not going to see, it's not going to kill the loopers. And so even out to 14 days, it's equal to what we saw control-wise with Besiege at 8 ounces plus acephate. So I feel like these are going to be uncommon. I haven't worked that quickly, but I think it was just a perfectly timed application. The larvae were small to medium size. The field conditions were correct. I mean, it was just nice and humid under that canopy, and it went out by airplane. And so, that was another caveat. It went out by plane. This was in Franklin Parish, Louisiana. This field was, realistically, they were just stepchild beans. They were late planted. They got about this tall. The rows never lapped. It was, that some ends of the field held water, others were dry, typical Macon Ridge soil. And so it was a really, really difficult scenario to make this virus work. And what happened is, we actually see it work. So the dark bars are non-treated, green is virus. This is our pre-counts for 25 sweeps, so we're running roughly 16 to 18 worms for 25 sweeps. At 4 days, the non-treated, we're still running at 16, 17 worms, where the virus is starting to knock them down below 10. Out to 8 days, we're starting to see a decrease in our numbers of our non-treated. And what happened here and here is the virus actually infected our non-treated. And so this virus moves very, very quickly. And so something that my crew and I did is that 4 days after application, this virus had moved 120 rows in the field. And so we sprayed 7 acres of a 200-acre field. And we kept it on one spot of the field so we could track its movement. And what we did was we walked and walked and walked until we found loopers that weren't dying of disease. We switched sweep nets every time, because with this, you can actually spread this virus around. If you get diseased loopers on your sweep net and you go sweep in another part of the field, you'll actually spread the virus, if you get it on your clothes. And so what we do is we trade sweep nets out, and we would make sure we weren't reinfecting the field. We would try as hard as we could not to get it on our clothes, and then we would move, and we found it moved about 120 rows. It's hard to quantify things in a straight line in nature, but that was our best guess. 8 days, it had completely spread to that entire 25 acre part of the field. By 14 days, we drove to the complete farthest spot away from where we sprayed, and we were finding diseased loopers. So I'm not going to discount that it could have been natural infestations, but there's a potential that what we sprayed may have moved that far. Now, in between pre-count and 8 days after application, we got 1.25 inches rainfall. So that may have helped move some of the movement as well. Now, I'm not advocating spraying just one part of a field and hoping it moves. It's just something that we saw. Yes, sir.
What would happen to the virus if you can't mix it with Dimlin at R3 and R5?
Compatibility-wise, it'll be fine. As far as you need the worms there to make it effective. So it is going to be broken down by sunlight over time. It's typically like an insecticide. You really need the worms to be there for it to be effective. And so it's not prophylactically. I don't see you're really kind of gambling with it prophylactically, hoping that it hangs around long enough for loopers to show up. And realistically, you really need insects to be there for it to make it work. pH, water pH is important. Extremely high water pH, I think over 8.6, is going to be detrimental to this. It'll actually break down the virus. So if you've got high pH water, you need to add a buffer to it, get it closer to, if you can, get it to 7. So that is a caveat we need to consider. Harold did a great, I'm going to anybody have any questions on worms, virus at all? So that's just identification. This is red banded. So if you ever have a question, if you need to know what a red banded looks like and you're really not sure, flip that dude over. He's got a spine right here. Essentially, where his proboscis meets on his underside, or his, on the dorsal, not the dorsal, the sternal side. If you imagine that, he's going to have a spine that comes up and meets his mouth parts right there. If you ever have a question, if it's a red banded, flip him over, and no other snake bug species has that right there. And it's very easy to see. You don't have to have you don't have to have a glass to see it. Okay, so and Harold did a great job talking about how much damage they cause and why they're different. Well, this is why. So this was some work done by DiPieri and Panizzi. Panizzi is the godfather of red-banded stink bug biology. He was in Brazil. The man has worked with this insect for his entire career, and I would be willing to bet there is no one on earth that knows more about this insect than this man. And he's a really good speaker. And so if you ever get a chance to listen to him speak, which nobody ever will because I'm a bug nerd and I like that type of stuff, he's great to listen because he can tell you more about red banded. He's forgotten more about red bandeds than I'll ever know in my career. So red bandeds probe significantly deeper than southern green stink bugs, 2 millimeter versus 1.2. So they're going to actually penetrate that seed deeper. They're going to feed not as long as southern greens. So they're 102 minutes versus 133. But they have more destructive saliva. And then the saliva spreads and damages tissues up to 3.5 millimeters away. So from that one puncture point, that saliva has the ability to spread 3 millimeters away and cause just catastrophic damage. And you can see in that picture here. So stylets, that's where the stink bug pierced the stylets into the seed wall, and then this is how far the damage spread from that one penetration. So you have the pod wall, this is the endosperm, and so that's the amount of damage one probe from a red-banded stink bug caused. So that's why these insects are so damaging. This is non-damaged seed, so this is a scanning electron shot of a damaged versus non-damaged soybean seed. And so that has chemical dissolution of tissue as the primary cause of damage. So non-damaged seed, you have protein bodies, Here, nice big circular protein bodies, what forms the protein of the seed. On a red-banded stink bug fed seed, you've got protein bodies that are shrunk, almost completely disappearing. This is a protein body here and here. So this is damaged versus non-damaged, non-damaged, non-damaged. And so that destructive saliva is extremely potent and causes a lot of injury in our soybean seeds. That's why we see the quality loss, the grade loss. What we see late season, the physical removal, they'll actually go after the oil. And so when they inject those enzymes into the seed, they'll actually keep causing injury. So this is some of Dr. Jeff Davis's work, and I get questions about this every year from our consultants and growers that, it's been a fairly cold winter. Are we going to have red bandits? Well, his research shows that at 23 degrees Fahrenheit, you need a lethal time of to kill 90% of the population. It has to be 23 degrees Fahrenheit for 7 hours. So to kill 99% of the population, or 95% mortality, red bandits have to be exposed at 32 degrees Fahrenheit for a week. So even though they're invasive and they come out of a subtropical area, they still require a pretty extreme level of cold for Louisiana to kill them. Last winter was a perfect example. So this was 2014 temperatures. Dr. Davis compiled this and was kind enough to share it with me. And so this is as of February 3rd, 2014, hours at or below 23 degrees Fahrenheit. You've got 23 at Ben-Hur, that's in Baton Rouge. Crowley, that's going to be around Lafayette. Dean Lee is Alexandria. Macon Ridge is Winsboro. New Iberia, Red River. This is the southern part of the state, the northern part. They've had a lot of hours below that number. This was last year. I compiled these numbers as of 2018. We blew 2014's numbers out of the water. And as a result, our red-banded stink bug populations in 2018 almost were non-existent because the cold completely took them out. Now for 2019, as everybody, you walk outside, it's actually kind of nice. And it's really going to be nice later in the week because we're going to get up to almost 80 degrees. And so that's not good enough for us to kill red bandits. Not even close. Yes, sir.
You said it was non-existent in the state or the north?
Both. Well, I got reports from the North Delta and Louisiana that I personally had to wait until the first week of September before I could get my red-banded stink bug tests out. And normally that's not the case. Harold, did you?
They were noticeably lower. I mean, we definitely got a nice benefit out of last winter, but we still had some.
Yeah.
I mean, it was just field by field. You got to look for them.
Yeah, and you're not going to completely eradicate them. Now, if we had an Arctic blast like they've got in Chicago going on right now, I'm pretty sure it would kill everything. I mean, red bandits, that would be what it would take. But at the same time, realistically, are we going to get cold enough in Louisiana to completely eradicate them? No. South Louisiana, we're too far south, especially down here south of I-10. It's subtropical in nature. Some years we don't even get below freezing. And so a lot of times what will happen is that clover will come out very early, and then the red bandits that are overwintering, or they don't really technically overwinter, they just kind of hang out during the winter. And so as soon as they have a host start to emerge, clover, they go straight to it. And so if you've got an early winter, a warm winter, which translates to a warmish spring, you've got clover popping out of the ground quickly. That's that much more time for those red bandits to infest clover and start reproducing. And so once that clover dies in May, June, you've got a big population of red bandits that are willing to pick up and just migrate into beans. And so that's typically what we see in a warm year. Last year when it was so cold, our clover was very low, very well delayed. I didn't see clover starting to come up until probably the third week of April in North Louisiana, which is about a month behind where we normally are. And really our population showed that as well. Let's see, I'm going to go through something else. I get questions on diamond. Diamond's an insect growth regulator, and so there's been some chemical dealers, depending on where you are in the state, that are claiming that diamond controls red bandits very well. The reality is diamond does absolutely nothing to red bandits at all. So we had diamond at 10 fluid ounces. It's no different than the check. Diamond plus orthene. Orthene is doing all the work. And so where we have a pound of orthene, you may have got a little bit of bump, not really significant. But where we had diamond at 10 ounces, that's $10 an acre, you're getting nothing. And so our threshold is 4 or 25 sweeps. And so realistically, orthene is going to be doing the heavy lifting. Don't rely on diamond. So management practices, populations are still going to likely be low in the north. Make a prediction, insects make me wrong every year. Colonization means you're already behind. If you've got immatures in that field, that means you're already behind. That means the female has come in, she's mated, and she's laid eggs. And so because the nymphs they can't fly. So what they're going to do is that first instar, they're going to feed on the egg mass, and then after they make it through that first instar, they're going to disperse and start feeding on pods. And so if you're starting to see immatures in a soybean field, you're already behind. Indeterminate beans are going to require modified scouting practices. Exactly what Harold talked about. So you're going to have to bend those beans back and look at the bottom, because you've got mature pods at the bottom and flowers at the top. Red bandits only are going to want to feed on the seeds, on the soybean seeds. They're going to be at the bottom. So you're going to have to almost get on your hands and knees and start looking. And subthresholds are causing injury. Just because we're hanging out at 3 per 25 sweeps for 3 weeks, they're causing massive amounts of injury in that field. And so my threshold as an entomologist, if you find an immature, that's a threshold because you're already behind. If you're sitting at 1 to 2 per 25 sweeps and it takes your aerial applicator 3 days to get to the field, tell them to spray now. Because by the time you come back, you might be at 2x threshold. You have to be extremely aggressive with these insects. We'll go through this just in the sake of time. So this is really kind of what Harold had talked about. One last slide. When we have 2 pound use rate of acephate in Louisiana. And so that goes very quickly. Something that we looked at was substituting lanate with acephate. The PHI is the same. Lanate has a 14-day PHI. So this is lanate at 16 fluid ounces. This is on nymphs. So this is the black bar is a pre-count, 7 days after application. This was a falling population anyway, but lanate did keep it below threshold. Acephate at a half a pound of sodium lanate. For the adults, pre-counts are going to be the black bar, 7 and 14 days. So by 14 days, we were up to threshold where we used acephate in the pound. It performed very well. Lanate at 16 ounces performed very well. Acephate at a half a pound and lanate at 8 ounces. So it does work. I don't know, lanate, something a little cause for concern. If you've ever worked with lanate, lanate's extremely toxic. Lanate's one of those where if you get it on you, you got to get it off pretty quick or you're going to regret it. It's not like acephate. Acephate, you can have a bag blow up in your face. It's not going to hurt you. Well, I say that. It's not going to be as bad. If you have a bottle of lanate break and wash all over your pants, you better find somewhere to take them off because it's extremely toxic. And if some of the younger guys, I tell this at my grower meetings, if you're younger and you've never messed with lanate, it's like Bidrin. You can't play around with it. You have to treat it with respect. And so it's one of those where you need to wear full PPE mixing it. And with that, does anybody have any questions? I know we have a break coming up next, so we can, if anybody has any questions and we run over, it's okay.
Two things I forgot to mention real quick was late season when you're sweeping soybeans and you get on a lot of mature leaves coming into your sweep net. Red-banded stink bugs have an uncanny ability, in my opinion, to hide in that debris. They're hard to find. You've got to turn every leaf over. And they'll play dead also. They'll play dead. The other thing I was going to mention was that for a lot of us, acephate as part of our control program is pretty darn essential. And through the National Cotton Council, we've been told that EPA has their sights on organophosphates, and acephate may be one of the first ones. So if you hear those reverberations, for the sake of us in the South fighting this pest, we need to learn how to get our comments in and make sure they know we really need this product for Louisiana soybeans. Just want to throw that out there.
Yep.
Or the MidSouth Soybean.
If we get 2 warm winters in a row, red bandits are going to make their way back in the North Delta again. I mean, it's just, they made their way so far north, was it year before last, that I know it's cold, but you have some lingering around somewhere, I would bet. Just because all it takes is a couple warm winters, and they will migrate to where the food source is. And so, all righty, make sure y'all sign the CCA sheet if y'all haven't, and thanks for coming.